Hello. Today I'll be discussing momentum, impulse, and the conservation of momentum. After I've established the definitions of these three terms, I'll carry out 3 experiments demonstrating each one.
Momentum can be represented by the equation P equals m times v, where P equals momentum, m equals mass, and v equals velocity. Momentum is defined as the quantity of motion of an object, aka mass in motion. Momentum is a vector quantity, and it's measured in kilos times meters per second.
Impulse can be represented by the equation F times delta t, where F equals net force and delta t equals change in time. Impulse is defined as the product of the force acting on an object over the time during which the force acts. Impulse is measured in newtons per second. Conservation of momentum, represented by F times delta t equals delta p, where F equals net force and delta t equals change in time, and delta p equals change in momentum, is defined as the total momentum of an isolated system remaining the same over time. This can be represented by kilograms times meters per second. In order to calculate momentum in this experiment, I will first set up a point A and a point B. Then I will place the object at point A and push it to the end of point B. In order to find momentum in this example, first assume that the object weighs 0.005 kilograms. Then, assume that the object moves at a constant pace of 2 meters per second across the distance from point A to point B. After we make these two assumptions, we can then multiply the two variables, 0.005 for m and 2 for v, in order to find momentum, or p.
For my second experiment, I will place the object down, then mark the spot that it's at. Then I will cause a momentum change by flicking the object.
The first momentum change that I cause will be large, and the second momentum change I cause will be small.
Despite the force exerted, these are still the same momentum change, since it is the same action that I am using to cause that change.
In order to find the change in momentum in the second experiment, you first need to write out the equation F times delta T equals delta P, where F equals force, delta T equals change in time, and delta P equals change in momentum. Since there are two separate instances of momentum affecting the object in different ways in this experiment, we'll have to write out two equations with different values for force, since it's obvious that in the first example of momentum being exerted on the object, the force is much greater than in the second example. The delta T in both of these equations will be the same, since although I exerted a different amount of force for the two different examples, I did do the same action, and so hypothetically, the amount of time it took for that force to be exerted upon the object would remain the same. After you've found those two variables for both of the equations, all you need to do then is multiply them to find the two respective delta P's.
For my final experiment, I will place two objects down a small distance away from each other. Then I will flick one object so that it comes into contact with another object, causing an elastic collision. It is clear that an elastic collision is occurring here, since one of the elements of the system moves after contact is made.
In order to solve for a missing variable using the law of the conservation of momentum, we first need to write out the equation which expresses the concept behind the conservation of momentum. In this equation, the left side of the graph represents the two different objects acting on each other during this interaction before the collision in the interaction. On the right side, these two objects represent the values of the two vehicles after the collision. For this reason, the mass for M1 or M1 apostrophe would be the same, just as the mass for M2 or M2 apostrophe would be the same on either side of the equal sign. This is not the case, however, for velocity, considering how one of the vehicles had zero velocity before the collision. This collision, however, would cause that vehicle to gain velocity. The amount of velocity this vehicle gains will have to be estimated for the purposes of this equation, as will the mass and the momentum. The missing variable we're trying to find in this equation is V2 apostrophe. It's important to add the apostrophes to the numbers on the right side of the equation so that you can tell which values represent before or after the collision. Although it may seem like momentum and velocity couldn't multiply by each other since they are different units of measurement, it's actually possible to multiply the momentum and the velocities in this equation. The result would include kilograms times meters per second as the unit of measurement. After you find the values of all the variables in the equation, you simply multiply those out and simplify them until you are able to isolate the mystery value on one of the sides of the equation. After you do that, you can divide the product in front of that mystery value by the other side of the equation to find what that value might equal, in this case what y2 apostrophe equals. In order to prove that, you simply plug in the value that you found for v2 apostrophe in this case back into the original equation with all the original values and see if those two equations end up equaling each other. Since, due to the law of conservation of momentum, the momentum ends up having to be the same every single way. So if the momentum is different, that means that you found the incorrect value for whatever value that may be in the equation. The conclusion of this problem marks the end of this presentation. Thank you for listening, and I hope you learned something.